Okay, now we start the videos for homework part C, and this has two subsections. One is rationalizing the denominator, which will be this video, and then the next video is rationalizing the numerator, both of which we have to know how to do. They're very similar though. So dividing, rationalizing the denominator. So let's say that we have a square root in the denominator. So we have square root of 16y to the fifth over square root of 2y. Now that's going to be, I could put those two together like that, and then divide the 16 by 2 and the y to the fifth by y. You get square root of 8y to the fourth. That's 2y squared times the square root of 2. So I didn't need, so they're rationalizing the denominator. What does it mean? It means that you end up with no radicals in the denominator. So notice when I did this, I ended up with no rational numbers in the denominator. Didn't have to do anything fancy. So sometimes, the point here is just sometimes it just works out the way you want it to. With the denominator is a 1, which is a rational number. That's what this means. Okay, so that one just worked out on its own. This one, well, it's going to be the square root of x. But if you don't see that right away, if you have a square root in the denominator, then the way you rationalize it is you can multiply the numerator and denominator by the thing that makes the denominator simplify, makes it the radicand into a perfect square. So to make x into a perfect square, you need to have x squared. So I multiplied by square root of x. And then if I do that on the bottom, I have to do it on the top. And so it comes out like this, x squared of x over, because the square root of x times square root of x is x, because we're assuming the quantities are positive. Right? So x is a positive number. And then notice the x's cancel, and you just get the square root of x. So x is greater than 0, not just because you can't divide by 0, but because of the square root. Square root of x means that x is greater than or equal to 0, but since it's in the denominator here, it can't be 0 either. So it's positive. Okay, so here's another example. Negative the square root of 25 over x cubed. So that's negative square root of 25 over the square root of x cubed. That's negative 5 over x times square root of x. Now I have a square root of x in the bottom. That's perfectly fine. Normally I would just stop there, but if it says rationalize the denominator, that means I need to get rid of this square root in the denominator. So I multiply by the square root of x over square root of x. And that gives you square root of x squared on the bottom, or just x. So this x squared, one of the x's is from here. The other x is the combination of these two. This times this gives you x. Right? And so I just combine x times x and got x squared. And then the numerator, of course, is just the product of these two. And there's a minus in front. Okay? So there's no radical signs in the denominator. Just a note here, a lot of people make this mistake. Never cancel a factor inside a radical sign with a factor outside the radical sign. That it will always be wrong. So you would not cancel this x with one of these x's. That's a square root of x, not an x. Okay? Okay, now here's a cube root one. Now cube roots are a little different. So I'm going to break this up. Cube root of 6a squared over 25b, I'm going to break that up into a cube root of the numerator over cube root of the denominator. And now I want to rationalize the denominator. neither of those things, 25 is not a perfect cube and neither is b, but I need to make them a perfect cube by multiplying them by something. If I multiply them by something, I have to multiply the numerator by the same thing. So here I need another 5 to get 125, which is a perfect cube, right? Because that'll simplify. So I need to multiply this by cube root of 5, not cube root of 25. The rule is not multiplied by the same thing. It never was, okay? The rule here is to multiply by something that gives you a perfect square, x squared, right? It just happens, with squares, it happens to be the same thing. It's coincidence, okay? With cubes or any other power, it's not the same thing. So here I've got 25. I need another 5 in there. So I need to multiply by the cube root of 5 on top and bottom. Here I have a b. I need 2 more factors of b, so I need to multiply by the cube root of b squared, top and bottom. If you don't understand that, listen to that a few times until you do. It's really important. This is the one that the most people mess up on because they're not thinking at all. They're just thinking, multiply by the same thing on the top and the bottom. No, by the same thing that you had before. This. That's not going to work. It's going to give you a perfect 4th power in here, not a cube. Okay, so think it through. So I'm going to multiply by those. See the difference? B squared. 5 squared, 5. 5 squared times 5 is b5 cubed. B times b squared would be b cubed. Cube root of b cubed is b. Cube root of 5 cubed is 5. See? So you end up getting this. I just combined everything in the numerator. The cube root, right? 6a squared, the 5, and the b squared. I colored them so you can tell the difference. Then, of course, you'll take the 5 times the 6 and get 30, right? And this is over this cube root. So the cube root of 125 is 5. Cube root of b cubed is b. So you end up with no radical in the denominator. And that's the answer. Now, you don't, again, you never cancel something inside the radical sign with something outside, no matter how tempted you are. The rule is not if something is on top and if a factor's on top and a factor's on the bottom, then they cancel. That's never been the rule. It never will be the rule. 30 is not a factor of the numerator. It's a factor of the radicand inside of this cube root of the numerator. It's a totally different thing. 5 is a factor of the denominator, but 30 is not a factor of the numerator, so you can't cancel. Okay? Never cancel something inside a radical with something outside a radical. Same with the b's. If you do that, every single time you do that, you'll get it wrong, and you'll end up doing that probably on maybe 80% of the problems, which means that you'll just decide you can't do these. I can't do these because you're doing some move that's not legal, mathematically legal.